Hello, Raiders. The purpose of this video is to give those students who are absent an opportunity to get the rest of the Chapter 19 notes. Additionally, it's possible we did not get to the end of the slideshow, or there's potentially even a math question that I wanted you guys to do on your own. Please do it in Cornell note style. Please number your notes, and also, I will be going a little bit faster than I typically do in class as it's a video and you can pause. All right, Chapter 19, Air Pollution. Here we go. All right, so the atmosphere, lowest layer is called the troposphere. That's where we live. Stratosphere is the layer above it. It's got a concentrated layer of ozone, and that's really important because that ozone layer blocks a lot of the UV radiation from the sun, which allows life to exist and allowed life to evolve. All right, so typically, as you get further away or as the altitude increases, the temperature decreases. The only exception is the stratosphere because it actually absorbs UV, which is a form of heat energy, and there's a slight increase in temperature as you're getting further from the surface. All the other layers, it gets colder. Troposphere is made mostly of nitrogen and oxygen. Less than 1% are all the greenhouse gases, all the pollutants. Stratosphere is similar in composition to the troposphere, but there's less water vapor. There are fewer clouds, and it also has that ozone. So ozone in the stratosphere is a good thing. Ozone in the troposphere is a bad thing because ozone acts as a greenhouse gas and it's also a pollutant. So ozone, where it should be, where we're not living, in the stratosphere is good, and where we are living is not so good. All right, moving ahead in 3, 2, and 1. All right, air pollution. We're going to abbreviate that. So industrial smog, photochemical smog. Remember, photochemical smog is partially created by reactions that the sun makes happen. Driving, obviously. Sources of air pollution. So there's natural ones. This is a big one, wildfires. VOCs. This doesn't mean like factories. VOCs, as you guys learned in the video, are naturally produced by plants. We're not sure exactly why they produce them. Anytime you see anthropogenic, it means human caused. So industry, urban areas, energy creating plants or electricity creating plants, and cars. Effects of air pollution. High concentrations of air pollution can actually harm organisms, us. There are a number of people around the world that die because of bad air. Ecosystems suffer. Also, air pollution leads to climate change, especially if we're talking about greenhouse gases. I'm moving ahead in 3, 2, and 1. Please use this as an opportunity to practice a little bit with your notes. List 2 things you learned about the troposphere. Go back to number 1 and number 3. That's where we live. It's got all the pollution, most of the clouds, mostly nitrogen and oxygen. Next question. 2 things you learned about the stratosphere. Take a look back at number 1 and 4. Yeah, it's got concentrated ozone. It's the layer above the troposphere. All right, moving ahead. The 4 sources of air pollution. Take a look back at number 6. Yeah, so there's natural and human-caused sources. Dust, wildfires, volcanoes are natural. Industry, urban areas, electricity production, cars. All right, so primary versus secondary air pollution. Primary comes right from the source. Secondary comes from reactions that take place in the atmosphere between different primary pollutants. In developed nations, it's much better since the 1970s, especially in the United States. We started creating a lot of environmental laws. Fine particles can cause cancer, asthma, heart attacks, or stroke. Lots of people die in China, in India, not quite as many in the United States. Um, but as you may remember from the air pollution movie, we mandate that you put scrubbers in the smokestacks of electricity production facilities. It's really expensive technology, but it cleans the exhaust before it goes into the atmosphere. Um, Developing nations like China and India do not do that as much. I'm not sure if they do it at all, but if they do, they probably don't do it as much because they don't have as much infrastructure as we do. Moving ahead in three, two, and one. Carbon oxides, everybody's heard of carbon dioxide. Monoxide is also a problem. They're both greenhouse gases, which both lead to climate change. Nitrogen oxides. Some nitrogen oxides are actually greenhouse gases. Nitrogen oxides react with water vapor in the atmosphere to form nitric acid, which, if it gets to the surface, is acid rain. Similarly, with sulfur oxides, they also react with water in the atmosphere and form sulfuric acid, which, again, if it gets to the surface, leads to acid rain. So, what happens is this rain has a lower pH and literally dissolves some of the minerals in the rocks. And as you can see, the faces on these statues are starting to get a little bit, they're lacking definition because those minerals are dissolving. Moving ahead in 5, 4, 3, 2, 1. Particulates. So this is something that we've become very familiar with in Sacramento in the Valley. That's the Dixie Fire last summer. It started not far from where I grew up. And it's the campfire. Obviously very, very bad air, very unhealthy to be out and breathing that air. And as you guys learned in the lab yesterday, smoke can actually decrease the pH of water. And if there's enough smoke and the pH lowers enough, it can actually harm aquatic plants and animals. All right, O3 is ozone. Ozone can lead to coughing, breathing problems, and it's also a greenhouse gas. So like I said, in the troposphere, it's a bad thing. In the stratosphere, it's a good thing. Volatile organic compounds, methane is one, benzene, some dry cleaning fluids. I'm moving ahead in 5, 4, 3, 2, and 1. All right, blank pollutants come directly from sources, while blank pollutants come from reactions in the atmosphere. If you can't remember, you might want to take a look back at number 8. Yeah, so primary come directly from sources, secondary are the result of reactions. Pick an oxide pollutant and identify its name, its chemical formula, and how it impacts the environment. So go take a look back at number 10, 11, 12, 14, 15. And of course, because there are a variety of answers here, I'm just going to let you get to it. Next question. What is one way smoky Sacramento skies affected you in the past years? Did it make you think about how you live? May or may not have made that second question think about how you live, but remember, um, drought is causing fires to become out of control. Drought is a consequence of climate change. Climate change is a consequence of too many greenhouse gases, and too many greenhouse gases is a consequence of using too much electricity, driving cars too much. Um, there are lots of things that we can do to help mitigate climate change, which indirectly down the road will help lessen the severity of wildfires. Moving ahead. So lead is toxic. Used to be in gasoline, hence the term unleaded gasoline. Does not biodegrade, which means that it can accumulate and magnify in tissues if it gets into cells. Human health problems, death, brain damage, paralysis. Some of you guys were probably as shocked as I when you were reading about how e-waste in developing nations, children are, you know, salvaging these components and don't have masks, don't have gloves, in very unsafe conditions. Of course, it's also toxic to animals and plants. Moving ahead in five, four, three, two, and one. Prevention and control. So pick two prevention methods, pick true control methods. Moving ahead in five, four, three, two, and one. Industrial smog obviously comes from industry. Lots of sulfur dioxide. H2SO4 is sulfuric acid. Also lots of particulates, especially if we're talking about coal. Burning coal, you get carbon monoxide, dioxide, and lots of soot. It's real common in industrialized urban areas, China and India, Ukraine. Beijing has the worst air in the world. Photochemical smog, there's Los Angeles. Just looks nasty. So UV radiation and auto exhaust is causing primary pollutants to go into reactions, and you get these compounds and the smog as a result. Moving ahead in five, four, three, two, one. All right, acid deposition. Acid deposition is a fancy word for, acid being deposited on the Earth's surface because of rain, acid rain. Coal burning, energy plants, cars. Coal burning, sulfur dioxide, cars, nitrogen oxides. Anytime you see NOx or SOX, it just basically means whatever number's there. It's a sulfur oxide compound or a nitrogen oxide compound. It's a big problem for aquatic life, especially. Also human health. And remains in the atmosphere for 2 to 14 days. Moving ahead in five, four, three, two, and one. What are two characteristics of lead poisoning? Take a look back at number 16. Yeah, it's non-biodegradable, which is a big problem because it can accumulate in tissues, can cause death, brain damage, paralysis. It's toxic to plants and animals and the environment. How's photochemical smog formed? Take a look at number 20. Yeah, so it's the sun's UV radiation and auto exhaust, and reactions are happening in the atmosphere to produce those compounds. Two characteristics of acid deposition. Take a look at number 21. Yeah, so SOx and NOx, it's a human health issue. A lot comes from coal burning, energy plants, and it stays in the atmosphere for 2 to 14 days. All right, moving ahead. All right, acid deposition problems leads to respiratory issues. It allows toxic metals to leach out of soil and rock. Causes bioaccumulation in fish, lowers the pH in aquatic ecosystems, which can harm organisms. Also damages forests. You can see these images. Acid literally killed all these trees. I'm moving ahead in 5, 4, 3, 2, and 1. All right, prevention and cleanup. So write 2 prevention methods and 2 cleanup methods. Moving ahead in 5, 4, 3, 2, and 1. All right, outdoor air pollution is decreasing. So gravity is literally causing particulate matter to settle out into the soil. Rain and snow pulls it out of the air. Wind disperses it, which makes the concentration less so. And some reactions in the atmosphere actually remove pollutants, which is kind of cool. That doesn't make sense. Factors that outdoor air pollution. Factors that influence outdoor air pollution, I'm supposing. Hills and mountains. So one of the reasons why we have a lot of pollution in the valleys because we have mountains to the east of us, and a lot of the pollution is coming from the west of us, from the Bay Area. High temperatures also, and temperature inversion. Inversion means opposite or upside down. So temperature inversion is opposite of what you would expect. So normally, as you get further from the surface, it gets colder. In a temperature inversion situation, you have colder air on the surface, and you have warmer air above it. And because cold air doesn't rise because it's more dense, it basically just kind of sits on the surface, and there's no mixing, there's no convection, and you get a lot of pollutant buildups. So again, this should be factors that influence outdoor air pollution. Moving ahead in 5, 4, 3. Actually, this should be factors that increase outdoor air pollution. My bad. All right, atmospheric brown clouds. So they're not just found in urban areas, found in the western Pacific Ocean. Dust, smoke, ash, soot. Hg is mercury, Pb is lead. Fires. Remember, some developing nations still use animal dung, those patties, to heat food. Ocean ships burn very, very gnarly, kind of nasty oil. Burning coal. Lots of deaths in China and India. You get less rain, warmer temperatures. The Himalayan glaciers are melting, more ozone in the lower atmosphere. Or we don't want it in the lower atmosphere, we want it in the stratosphere. Albedo is reflectivity. So if you have soot settling on the ice and it's getting into be a darker color, it's absorbing more sunlight versus reflecting more sunlight, which leads to more melting, warmer air, more melting again. Remember, positive feedback doesn't mean it's a good thing. Positive feedback means that the result makes the reaction, the phenomenon happen again and again and again and again. All right, moving ahead in 5, 4, 3, 2, 1. All right, what are some negative impacts of acid deposition? Take a look at number 22. Yeah, respiratory issues, toxic metals get released from the soil or rock, it accumulates, lowers pH, damages forests. 2 ways to prevent acid deposition. Take a look back at number 23. Yeah, reduce use of coal for electricity, use natural gas and renewable energy sources instead of coal, remove SO2 and NOx from smokestacks. So we use these things called scrubbers. Those are all ways to prevent it. Are 2 things that help reduce outdoor air pollution. Take a look at number 24. Yeah, gravity, rain and snow, wind, some reactions. Moving ahead in 3, 2, and 1. All right, so some math problems for you. Please write down all of the given information, especially those of you that are planning on taking the test, the AP test. These are legitimate types of questions you could see. If you don't write down all the information, you're not going to be able to understand what your calculations mean. I'm moving ahead in 5, 4, 3, 2, and 1. So according to the graph, the 4-year period would be from '01 to '05, and '01, the size of the hole was 12 million square kilometers, and '05, it was 27 million square kilometers. Calculate the average rate of increase. I'm starting to see a trend. Average rate of increase in the hole in ozone layer in millions of square kilometers per year. All right, so I'd like you to pause the video, see if you can work out this calculation before I show it to you. Solutions coming in 5, 4, 3, 2, and 1. All right, so it's 27 minus the 12 divided by the 4. That's 15 divided by 4. 3.8 million kilometers squared per year. All right, ladies and gentlemen, that is it for the Chapter 19 notes. See you in class.